Let's solve this electric circuit diagram. The information given says, in the circuit diagram below, the battery has an EMF of 6 volts and negligible internal resistance. Negligible internal resistance means that we don't need to worry about it. Now, question 7.1 says, calculate the effective resistance of the circuit. Now, I want to figure out what's in series and what's in parallel. To do that, I'm going to take a highlighter and I'm going to highlight the path of current. So current is going to leave the positive terminal. When it reaches this point, the current is going to split. So I'll use purple for one branch, and I'm going to use yellow for the other branch. Now at that point, the current is going to join up again and go back to the battery. So we can clearly see that we have two branches that are connected in parallel. So to work out the total resistance, we have to do a parallel calculation. However, we should be careful here because the 4 ohm and the 2 ohm are on one branch. And so they are in series in that branch. So what we need to do is add those two. So 4 plus 2 is 6. So this branch has a resistance of 6 ohms. Now we can calculate the total resistance, which is the parallel. So 7.1.1, we're going to say that R total is going to equal R parallel. Now 1 over R parallel is equal to 1 over R1 plus 1 over R2. That's equal to 1 over 6 plus 1 over 3, and that's equal to, now we put that in our calculator, 1 over 6 plus 1 over 3, so that's 1 over 2. Now that 1 over R parallel is equal to 1 over 2. We don't want 1 over R parallel, we want R parallel. So we switch the numerator and the denominator, and we do that on both sides. So R parallel is equal to 2 over 1, which is 2 ohms. That means R total is also equal to 2 ohms. Now let's take a look at 7.1.2. Calculate the reading on ammeter A1. A1 is, you can see that it's highlighted in green. So for our example, green represents total current. So we want to calculate total current. So the formula is I total, so total current, is equal to V total over R total. So the total voltage of the circuit is 6 divided by the total resistance of the circuit, we worked it out now, is 2. So 6 over 2 is 3 amperes. So A1 is 3 amperes. 7.1.3. Calculate the reading on ammeter A2. Now A2 is reading the current in that purple branch. Now there's actually a few ways we could do it. And one of the ways is if we think about how can we calculate current. So the current is going to equal V over R. Now, what is the voltage for that purple branch? Now, remember, the voltage in parallel is the same. So because there's nothing connected in series, I mean in that green section, the voltmeter reading here, 6, is going to be the same as if I connected a voltmeter here, 6 volts. So that purple branch and that yellow branch is going to have a voltmeter reading of 6 volts. So 6 divided by, and what is the total resistance of that purple branch? We worked it out, is also 6. So 6 over 6, 1 ampere. So the reading on A2 is going to be 1 ampere. You could do a ratio method that will also get you the same answer. Question 7.1.4. Calculate the power dissipated by the 4 ohm resistor. Now, we can calculate the power. There's a few equations. Power is equal to V times I. Power is also equal to I squared times R. Power is also equal to V squared over R. Now, we must be careful because if we want to use this formula or this formula, the voltage that they are talking about is the voltage for that 4 ohm resistor. Remember, the whole branch is using up 6. So sum of it Some of that 6 is being used up by the 4 ohm and the rest is being used by the 2 ohm. So we'll have to do a calculation to work out what voltage each one is using. So if you want to go that route, you can. It's just an extra calculation. But the other option is use this equation, because we know the current going through the 4 ohm resistor and we know its resistance. So I'm going to use that one. I'm going to say power is equal to I squared R. We worked out the current going through the 4 ohm resistor. It's 1. So 1 squared times the resistance of the 4 ohm resistor is 4. So 1 times 4 is 4. So 4 watts is the power. Now question 7.2. What is the reading on voltmeter V? No calculation is required. So we mentioned this before. It is going to read 6 volts. Why 6 volts? Because the EMF of the battery is 6 volts and there's only a parallel combination in that circuit. So each branch in that parallel combination is going to be 6. Question 7.3. A kettle is rated 1500 watts. Calculate how much a learner will pay for electricity for using the kettle for 4 hours. ESCOM charges 1 kilowatt hour electricity at 2 Rand and 5 cents. So the first thing we must do is we need to convert 1500 watts is equal to 1.5 kilowatts. So that's the first thing we need to do, because we can see that ESCOM is charging for a kilowatt, right? Next we need to do is we need to multiply this by the time. So it's 1.5 kilowatts, and then how many hours are we using it for? It's for 4 hours. So times 4 hours. So 1.5 times 4 is 6. So this is 6 kilowatt hours. So if 1 kilowatt hour is equal to 2 Rand and 5 cents, 6 kilowatt hours is going to equal 2 Rand and 5 cents times 6. So that's going to equal 12 Rand and 30 cents. Okay, thanks so much for watching. Don't forget to like, share, and subscribe. I'll see you in the next one.